We're going to chat today about inequalities, but they're going to look a little different. And here's what's going to happen now. Before, we'd only have one inequality we'd work with. We'd figure it out, we'd graph it, we'd be done. Well, now we're going to have either a really long one, or we might have two in it within a problem. We still do everything the same way. It's just now, well, there's a little more of it. So to help you out up here at the top, I drew up a couple of examples to kind of let you see what these typically would look like. Made a couple of notes again here in case we'd forgotten over what we'd been doing over last week. That, oh yeah, if it's or equal to, I'm going to have a closed dot there. And if it's not or equal to, it's going to be open. And then again, how to figure out which direction my arrow is going to go. So what I want to do down here at the bottom, and again, we're trying something a little different, is I've done some of the graphing for you. But what we're going to do is we're going to do each one separately and see where that answer graph is coming from. So here's how this is going to work. We're going to make ourselves a couple of number lines here underneath. Because these are already solved for the variables. So we don't have to do any solving on these. And so for this first one, I'm going to make myself 3 lines here. I'm going to put my number that I want it to be, in this case the -1 in the middle. 1 less would be -2. 1 more would be 0. And I'm going to graph this. So like for instance on this one, it looks like the arrow's eating B. Okay, or like it is here with X. Means my arrow's going to go right, but what type of dot am I going to put at -1 before I make that arrow? Is it going to be open or closed? Open, because it's just greater than. And that's going to be going to the right, and that matches up with our first one. Now, are we going to have to do this in every single one? No. But I want you to see where these graphs come from. So if I do the same thing with my b is less than or equal to 3, again, I put 1 less and 1 more on there. I notice a couple of things that are different on this one. First thing I notice is there's a line underneath my arrow, so the or equal to means it's going to be a colored in or a closed dot. And it also lets me know b is less than, the arrow's pointing at b. When that occurs, my arrow's going to go left because it's less than. Now, here's the thing that gets a little more interesting, and in future ones, I think we'll put the same numbers on both of these. Because some of you are going to say, oh, they're going opposite directions from each other, which isn't completely the case. What's going to happen here is when I look at the one down at the bottom that's done, if I were to look at them again, I'd say, oh, here's my one that started at -1. It was going to the right. Here's my one that started at 3. It was going to the left, and they kind of crash in the middle. So my actual graph at the end, I don't want them to go all the way through there. They just connect at the end points. So when you have an and in the middle, typically what's going to happen is you're going to have 2 dots on the end, and they're going to smash together in the middle and just kind of make a segment of some sort. Now, will that happen every time? Maybe not, but it can. So like if we were doing that on even the second one, if I were to cover that up for a second, well, let's even cover this arrow up. Now this is tricky because we like our variable to be on the left. Q is less than or equal to 2 because again, the arrow is pointing at my Q. So if something's less than, it goes to the left. So this part of 2 down here, if I were graphing it originally, would have an arrow going to the left. So you're like, okay, but then when I do the other part, and I look and I'm like, ooh, the arrow's eating my variable, so my arrow's going to go to the right, and there's a line underneath, so it's going to be closed. There's my closed dot. My arrow's going to the right, and again, they're on a head-on collision course where they're just going to crash in the middle with my 2 endpoints. So anytime I see the word and, or I see a big inequality like this, which is where the word compound comes for many, basically that's what my graph's going to look like each time. I'm going to look at each one. X is greater than, so my arrow's going to go right, and I see that. Open circle, because it's just the arrow. So I see where that's coming from. When I go to the other one, again, I'm just doing it's like it's two separate problems I'm doing. X is less than or equal to 4. Or equal to means I color in the dot. X is being pointed at by my arrow, which means it's less than, and it's going left. And they just crash in the middle. Now there are a couple down here at the bottom for us to be able to do on our own.
Do you have a Meton and a Jones here today?
I have.
Heather Meton maybe and Adriana Jones?
I have the first one.
Okay, she needs to come to student services.
Okay.
All our stuff.
So here, on number 5, be careful, especially on this first one. Let me scoot it down so I can see my notes here a little bit. Arrow eating D. Arrow eating X. My arrow is going to be going right. So I go to -3. I put my circle. And I just figured out the arrow is going right. So I'll make my arrow go just long enough that it can go to the right. Then I do the same thing for the other one. If D is less than 2, arrow's pointing at D, means it's going to go left. Is my circle on 2 going to be open or closed? Open, because I don't have a line underneath it. And it goes to the left, and they crash in the middle. So that's kind of the hint that we get on these. Whatever word's in the middle tells us what it's going to look like. Or if it's a big one like this, we talked about one of those up top. We said, okay, we're going to look at these a part at a time. But again, be careful. If your variable's on the right, I can't just follow the arrow. Because you notice how the arrow is eating that P? I come back down. Arrow eating the variable means my arrow's going to the right. Ooh, that's going left. So if I just follow that, I'm going to be in a little bit of trouble here. So I come to -1. Is this dot going to be open or closed? Closed, because we've got the or equal to. Okay. We said greater than is going to go to the right. And once I graph that, I'm going to switch over. I'm going to say, okay, P is less than or equal to 3 because the arrow's pointing at P. Okay, arrow points at my variable. My arrow's going to go left. So I get to 3, close dot because of the or equal to, and they come crashing together. And we're set. So that's all there is to it when there's an and. When you see an and, you know basically it's your two endpoints and I'm coloring in the middle. Now will they always be and? No. If I flip over, the word in the middle changes. The word in the middle. Okay. The word in the middle becomes or, which means something a little bit differently. When I do an or, typically what's going to happen is that I'm going to have arrows that are going away from each other. Just the same way that when I did my and, it was kind of like looking like a dumbbell. Got the weights on the end and the bar in the middle. Ors are just the opposite. They go away from each other. They want to get away from each other. So when we're doing these, and we'll kind of look again to see how this works. If B is greater than 2, I put my circle on 2, and it means my arrow's going to the right. Okay. Or, again, the word is key. B is less than or equal to -3. Well, less than goes left. But you're like, but they're not crashing together. That's right. They're not going to have a bunch in common. They're going their separate ways. So that's typically what or is going to mean. They're going to go out from each other. Now, can there be an exception to this? Yeah, there can be. And here's the one exception. here, I've got q is less than, the arrow's pointing to q, or equal to 3. Negative 3. Why am I at negative 3? That's weird. Okay. So I get on here, and my arrow would be going to the left. When I'm at 1, the arrow's also pointing at q. Well, wait a minute. They're going the same direction again. So I'd be sitting here and I'd say, well, wait. If I'm going left, I'd go ahead, but you're like, but they're going the same directions. How does this work? If they both go the same direction and it says or in the middle, you use the longer one, because or means it can work for either. It doesn't have to work for both, but it can work for either. So in this case, my solution would be the longer one. It would be my red one here, is the one that I would write down as my answer. That doesn't happen very often, but it does occasionally. Most of the time with these, what's going to end up happening is that we're going to end up with one going to the left, the less than, and one going to the right because it's greater than, because the arrow eats my y, and they go opposite ways. So let's see if we can use those to help ourselves out and maybe do number 10 and 11 here. So when I get here, I'm going to do this one in this color. We'll do this guy in this color. All right. First thing I've got to realize is the arrow's eating p. This is greater than. That means my arrow for this one is going to go right. So I go to my 4. I see the line underneath. Means I'm going to color that in. And my arrow is going to go to the right. Even though that one looks like it's going to the left, I got to be careful. I got to know. If that arrow is eating my variable, I'm going to the right. When I come over here, the arrow's pointing at the p, which means less than. Which means my arrow is going to go to the left. Now, this is an interesting situation. First, you're like, there's no 8 on the graph, Harty. Well, let's get it on here. So what happens here? Do they just crash in the middle? Because that looks just like an and statement. Normally, I'd say yes, but here's what happens in a case like this. Because the or is there, actually, this is going to go straight on through this one, and my red one's going to go straight on through here. So here's what my final graph is going to look like on this one. I'm not going to put all the numbers. I'm just going to put some of them here. What's going to end up happening on this is, if it says or and they crash, you just put your line all the way through, because every answer works. So let's kind of make a note here. If our or statement crashes together, my arrow is going to go on forever in both directions. So it's completely different from when we get an and in there, and that's why it's important to have this jotted down, so when you see it on a quiz and you're like, now wait a minute, how's that work again? You're going to have an example right there to work with. And I think we got one normal one left to do here, and then we can take a look at some of the homework ones and kind of see how we build into this. So, all right. Arrow eating D, that's greater than. Means my arrow's going to the right. So negative 3. My arrow is going to go to the right. Then I look at D is less than 2. Arrow pointing at D. That's going to the left. You're like, oh crap, here comes another one of those. They look like they're going to crash, but I know better. When they're going to crash, I go all the way through. So here's how this is going to work for what we do. Because I figured we've done so much with equations and solving them that I didn't put a lot of those on here. I wanted us to just get to the use to the graphing part of things. So when we actually get to the homework, and I'm going to work through several with you to give you a really good kickstart here. This is going to be our homework sheet with this. And just a reminder, for some of you with kind of keep working with your organization here, at the very least, write on here which homework check it is and what number one it is that we're working on, because that's how we're going to work on these. So this is going to be in homework check 9, which again will be Monday. This is going to be assignment number 3. And what we're going to do is we're going to do a couple of different things. We're going to write the inequality on this first one, then we're going to graph on a couple, and I'm going to get you a really good start here. You're only going to have a handful left to do on your own after this. So write an inequality for the following graph. Okay, I'm going to do it part at a time. I'm going to forget the other part exists. Looks like I got a dot here at -5. If my arrow's going to the left, is that less than or greater than? My values are getting smaller as I go to the left. So is that less or greater? Less. And I also know, do I need to put a line under my arrow or not? Yes. Okay, so that gets this part taken care of. Then I switch over. I say, okay, let's look at the other part. They're going apart from each other, which lets me know it's or, because ands come together. So I got x and I got 0. Greater than or less than with my arrow going to the right? Values are getting bigger, so it's greater than. Line under the arrow or not? No, don't need it. And I'm done with that one. I was just writing out what the actual inequality is, bless you, for the graph that they give me. Now the next one says I need to graph it. Notice I don't see or anywhere, which means this is an and. So remember, if it's an and, all I have to do, I know those are going to come together and crash in the middle. So I notice at 3, I need to close my dot. At -6, I notice there's no line under my arrow. So that's going to be open. And I'm like, oh yeah, with the ands, I just color in the middle. It doesn't go all the way through like it does with or. I just make my kind of dumbbell looking shape and I'm done. Now, there are some on here that I actually have to do a little solving on. So like for instance, let's say we're doing number 4. You skip number 3 for right now. I want to get n alone in the middle, sort of like x is alone in the middle in number 2. So if I'm multiplying it by -3, how do I undo it? Close. How do you undo multiplying? Divide. Now here's kind of our review from last week. What happens when I'm dealing with inequality and I divide by a negative? What happens to the arrows? They switch. So I'm going to switch my arrows. My n's alone in the middle. Negative times negative is positive. 9 divided by -3 is -3. But I still end up with a compound inequality. I still end up with an and, which tells me, oh, it's just going to be circles I'm playing with here. Okay, so -3 will be open, no line underneath. 1 will be closed. And again, with an and, basically I'm just making like a barbell out of it. I'm just coloring in the middle. So I may have to solve a little bit, and that's okay. But the ands are going to come together in the middle for me. Now 5, a little different. I see the or in the middle. That or tells me that typically my graph is going to look something like this. But I'm only going to do these one at a time. So I'm going to forget about the fraction for a minute. b minus 6 is less than or equal to -13. How do I dump the -6? How do I undo it? Here's some add. Okay. So negative 13 plus 6 is negative 7. Okay. We're just going to solve them here at the first. We'll come back and graph them. You switch over here. Now over here I'm dividing b by 10. What am I going to do to undo dividing by 10? Multiply. So b is greater than 10. Notice no flipping of arrows. There weren't any negatives I was playing with. So I get those in there. And I say, okay, let's graph these. b is greater than 10, which means my arrow is going to go to the right. Here's my 10. Open circle. To the right, looking good so far. Now, negative 7, that's a little trickier because I really don't have a negative 7 line. It's just here between these two guys. So I'll just make a dot in between that's colored in, closed because of this. And b is, the arrow's pointing at it, which means less than, which means it's going to the left. And I'm good. So whenever I'm doing these, I'm solving them like a regular equation. It's just I'm doing a little arrow at the end, but I have a clue of what it looks like depending on what the word is in the middle. All right, let's see if there's something that looks not fun back here in the back. All right, let's do 7 and 9, and then I will have you work on the rest of them here. Now, 7 is a little more interesting because my first job, and this is an and, because of the compound, is to get negative 10 by itself. So how do I undo a positive 5? We did. How do I undo a positive 5? Minus. And I got to do it to all three parts when I see the arrows in there. Okay, I don't do it to the minus 10 because that's included here in the middle. So those will wipe out. So I still got negative 10x in the middle. Negative 95 minus 5 is negative 100. And that's going to be 50. One step to go. I got to undo multiplying by negative 10. How?
You said what?
How do I undo multiplying by negative 10? Divide. Now, I got to be careful here because I'm dividing by a negative, and we know what that means. Gotta flip the arrows. Negative 100 divided by negative 10 is 10. 50 divided by negative 10 is negative 5. As long as I remember to flip my arrows, I'm going to be in good shape here. Because I'm like, oh yeah, it's an and. So let's see. Negative 5, there's no line underneath. So I'll open circle it. At the 10, though, there is a line underneath. I'm going to close circle it. And again, those ands typically are just going to make a barbell. Just going to color in the middle. Nothing too bad. Now again, that's different in looks from a problem like, let's say, number 9. Because number 9, I see that or in the middle, which typically means my arrows are going to go out from each other, but I still got to solve these separately to see what's going on. Got to get that 10n by itself. I got to undo the minus 9. So I add that to both sides. And then I got to undo the times 10 by dividing by 10. And once I have n by itself, I can graph this. So I notice it's going to be an open circle at 8. There's no line underneath. I notice n is greater than. Greater than means my arrow is going to go to the right. So if this is a normal OR, when I do the other one, the arrow is going to go to the left. I have all these little hints just by the little word in the middle. So let's see if that actually works. So when I get done with the one on the left, it's completely solved. I've gone ahead and I've graphed it. Then I'm going to go over here and I'm going to say, okay, now my job is to get this -7n alone. I got to undo the -8. So I'll plus it. And here's where I got to be careful, because it might be tempted. You're like, look, and add 7, but that's not what we're doing here. This is -7 times n. So I'm going to divide by -7, which means I've got to flip the arrow because I divided by a negative. And I get my answer for that one. And I notice, I go, okay. Now, if I'm looking at this one, the arrow's eating n, and that arrow went to the right. Here, the arrow's pointing at n, so the arrow's going to go to the left. And that makes sense because they're supposed to be opposites. They're supposed to go out from each other when I get those. So your job is going to be to finish the 1, 2, 3, well, that's not bad, 4 problems. Oh, yeah. And it also gives some of you an opportunity to get some stuff situated from last week if you need to be catching up on those first couple of assignments from the homework check.